Hello, everyone, and welcome. Thank you for joining us today for our webinar event on Next MBR. I'm going to take a moment to do a couple sort of intro notes as the audience enters the Zoom room here. So before we get started, a few quick housekeeping notes. Today's session is going to be recorded and will be made available to all registrants for on-demand viewing. We're going to share the link to all registered attendees after the event. If you have questions for our panelists as we go along, please use the Q&A tab or the chat tab at the bottom of your screen. We'll be monitoring those questions as we go along, and we'll have some Q&A at the end of the presentation. We're also pleased to share a new white paper from the teams at Integrated Water Services and CROM to all registrants, furthering the conversation on today's topic, which is, of course, the plug-and-play permanent plant, technical strategies for multi-MGD capacity via modular growth. For decades, the water industry has operated under a familiar trade-off: deploy fast with modular systems or build to last with traditional civil infrastructure. Next MBR was designed to eliminate that choice. Today's session brings together the engineers, executives, and project managers who built and delivered the first permanent concrete modular wastewater system, and we will use a real project, the McKinney Roughs Nature Park expansion outside Austin, as the technical blueprint for everything we cover. Leading our discussion is Todd Bernetti, Senior Vice President of Municipal Solutions at Integrated Water Services, who brings nearly 30 years of hands-on experience across every stage of water and wastewater infrastructure, from pipe layer to plant operator to system designer. Joining him is Bobby Oyanarte, CEO of CROM, who leads a 700-person organization with 28 years of experience in water infrastructure design, construction, and restoration. And rounding out the panel is Steve Mendoza, Senior Project Manager at Jones-Heroy Associates, a civil and chemical engineer with 35 years of Texas water infrastructure experience, including work with the TCEQ, the Texas Water Development Board, and the EPA. And I believe we've got everyone on camera here, although we may have some camera difficulties, so bear with us. Folks will be appearing throughout the presentation. Together, those three will walk through the convergence of MBR technology and ACI 350 concrete construction, how to align capital investment with actual demand, and what truly integrated design build delivery looks like in practice. And so with that, let's get started. I'm going to hand the mic over to Steve first to deliver some of the broader context here.
Right. The concept for this treatment plant far exceeds any of the MBR plants that I've worked with in the past years. It's a very clean, concise, well thought out design. It is easy for the operators to maintain, which is one of my primary concerns. I just can't express how nice and neat the plant is. In appearance, it's concise, the design. The nice thing about this is that it can be expanded to meet the needs as communities grow or developments grow, which is really nice. The effluent quality is excellent. Texas has some very strict effluent permit limitations, and depending where you are in our hill country, they get super stringent. This plant has no problem meeting any of those requirements. The whole package is probably the best treatment plant design that I've had the privilege of working with in the past 35 years.
Yeah, I think just to bolt on to what Steve's saying is we call this the permanent solution to decentralized facilities. And the reason for that is the 50-year design life and a useful life many years and even decades beyond that, due to the high durability and long-lasting shotcrete system. And I think that's an important designation because most of the decentralized facilities that are in Texas are maybe 15-year life. And this is a system that's meant to be around long after all of us as a permanent solution.
Yeah, and to go ahead and add to Bobby's comments there, the strategy and the partnership with CROM here as we push forward with this design was to provide a solution that, your towns of your smaller municipalities and could have all the benefits of long-lasting infrastructure assets. to carry them into their future as they expand their systems.
Yeah, so last but not least is in Texas, the Texas Commission on Environmental Quality and the EPA for the longest time have wanted regional wastewater treatment facilities. The problem with that is that as these cities grow, you start transporting wastewater over incredibly long distances. And with a combination of detention time in transit, plus the number of lift stations and force mains, you get a high level of hydrogen sulfide being generated. So not only does this tear up the lift stations, this also deteriorates the headwork structure of the treatment plants. So being able to decentralize these treatment systems really is a big advantage. As far as the operators in the system, they're not having to worry about being exposed to dangerous levels of hydrogen sulfide. As far as the equipment, you don't have to worry about it reacting with the hydrogen sulfide. I mean, hydrogen sulfide through biological reaction will cause concrete to be dissolved. The hydrogen sulfide reacts directly with the metal. And depending on how bad the concentration is, it can literally eat some of the better stainless steels. So this is actually a really nice concept to address all of the issues that we deal with in Texas.
So as we were developing the model for the next MBR, and we wanted to come up with a seamless solution. So vertical integration is key when you get to seamless solutions. A big problem we saw is that the entire process train wasn't being provided, as a package. Next MBR allows us to have a single process design, single platform, and it's designed around operators with operators consideration. Steve can speak to this a little later, but one of the big key points we do here in partnering with CROM on this solution is we got a lot of input from operators across, all facets. And while, we have smaller modular solutions, we really believe that the next MBR, as, the decentralization boom, expands, that you're going to see more and more of this and the need for an expandable platform. Next slide. So one of the big constraints for smaller municipalities or private utilities or developers is your CapEx. So in order to get into, a facility with uncertain growth potentials, with the housing market having ups and downs, having a modular approach that's scalable, that's fast to deliver is really key here. We designed Next MBR in 250,000 gallon a day increments, all the way up to a 1 MGD module. And then it can be expanded out in 1 MGD modules from there going forward. So they're only paying for the infrastructure they need at that time. And as we get further down into these slides and we get to the case study, we'll point out how we were able to do that at that particular location, McKinney Roughs here in Texas. So as we can control their capital outlay, then they have a client base and a stable, financial platform to account for infrastructure expansions at the right time.
We're also able to eliminate the risk model and the conundrum of the Spearman doctrine, where
Right.
we still partner with the engineering houses, but as far as the risk of ownership for the design liability, it lies with the fully vertically integrated design builder. When we talk about Next MBR, what's really amazing is this is the first system to incorporate an entire vessel widths process, okay, and meant to last the test of time. And we do that with a technology called CROM squared, and it is a technology that really has been being used for 74 years. And we've taken watertight details, construction methodology, and and all that experience, and rolled it up into this new tension shotcrete system that provides, like I said, a 50-year design life with a useful life that goes far beyond. And the way we're able to do that is we're able to do it utilizing the robust ACI 350 design, right? With minimal really robust ACI 350, but then also the water tightness of D110. And so we've combined those two really exceptional standards to build by, to create this really great vessel to house the MBR system. And some of the things you might think about, if we go back one, is, as Steve mentioned, and Todd actually, when we talk about capital efficiency, the shotcrete system and the way that the corners are designed allows us to really expand it in a couple different ways. We can go in any different direction, and do the phased approach by making the connection to the existing structure. Or the other way you can do it, depending on the site constraints, is you can get very close to the other structure. And we can have a work road as little as 10 feet if you want to have independent trains to build out your phases.
We addressed capital constraints and we start looking to solutions and delivering to market. We work through a lot of different parameters, and one of the best ones we found was being able to vertically integrate. So when we can take CROM's superior tank technology with a 50-year life cycle, we can couple that with process design based around MBR technology for the highest quality effluent we can generate. And then we take instrumentation controls and we put all of that into a single modular package. It basically provides an atmosphere where you have influent in and effluent out. In other words, we handle the entire process design with the next MBR. We have the headworks design. We have all the different zones within the tank, all the processes, all the controls. So you have a completely vertically integrated design, which reduces overall cost to market, and it lowers the capital constraints of entry for larger facilities.
Yeah, and it, as I mentioned, with the Spearant doctrine, it eliminates the division of responsibility. The CROM IWS CROM team produces a single point of responsibility for the next MBR.
Yes. Next slide. So for our case study here, we wanted to use a facility that's been in operation for a little while now. And this is going to get us to the McKinney Roughs case study. So McKinney Roughs was a Corex Utilities facility located in Bastrop County, Texas. And that facility was originally designed around a conventional activated sludge facility. And when the 60% design numbers came in, we were looking at a budget of right around $14 million overall. The desire to pivot and start doing some value engineering is what led us to the partnership with CROM at this location. And so we pushed forward with a new design. We're able to reduce the footprint by 60% and increase the construction time because they did have deadlines. Next slide, please. So out there at McKinney Roughs, we discharge the Colorado River Basin in that area. So the effluent requirements were really tight. And when we were looking at a conventional activated sludge facility for that location originally, tertiary treatment adding to it to get to the same effluent quality you could do with MBR, we decided to pivot to MBR. And through value engineering, reduced footprint, construction time, we were able to deliver this project in 12 months, running some of the design concurrent over the top of construction efforts. The tank itself, and Bobby will get into some of the tank construction here in a little bit, was constructed in 13 weeks. And we were able to do the rest of the site civil and the balance of work in quite an expeditious fashion at this location. Next slide. So scale. So we went and we took a look at that facility, and originally they had a 36,000 gallon a day MBR plant on that location, and they needed to be able to go from 250 to 500,000 gallons a day initial phasing. So what the next MBR allows you to do on this location is in the exact same footprint that you saw in 2 slides earlier. You can go from 250,000 gallons a day to 500,000 gallons a day in that exact same footprint, which is 71 feet by 32 overall. Meeting the regulatory requirements, there was a lot of protest on this particular discharge permit. And so you'll see in a lot of the photos that it is set up for purple pipe. We went ahead and designed this facility around Title 22 regulatory compliance. So it'll meet the tightest reuse standards in the nation at Title 22. Next slide.
So when you think about the integrated approach and the innovative technology, right, as CROM's been delivering innovation in the water industry, except for 74 years, through 24 different patents and this patent pending technology. The idea is simple, right? It's keep all the water inside the tank, and in this case, all the wastewater inside the tank. The structure is designed to be hydrostatically watertight and hydrostatically independently watertight, meaning each chamber can be filled or emptied at any given time and maintain water tightness for all the other chambers. So we're not mixing, there's no chance of mixing aerated water with MBR water with anox water, or EQ water back into anox water. Okay. The entire life cycle delivery is really important through the vertically integrated process. And in this particular case, through the McKinney Rough, IWS took the lead. And in projects, depending on where the projects are, it can go either way. CROM can take the lead or IWS can take the lead. In this particular one, IWS was on the front end with the permitting and handled the design of the site, and then CROM partnered towards the middle to accelerate the structural design and the construction scheduling, such that we ended up, as Todd mentioned, we shaved over 50% of the total duration off of this project. And the way we're able to do that is through a seamless vertically integrated approach. And this is the first ever MBR structure housed inside of a watertight tension shotcrete containment system with a 50-year design life.
And one thing I want to capitalize on there, Bobby, is the original pricing for this facility came in at roughly 14.2 million, well beyond the client's budget. And as we pushed forward and did the value engineering, we were able to deliver this site for 7.8 million, which is just sub $30 a gallon overall.
The one thing that I think is amazing is I have been doing this a while. And, wastewater treatment way back when was like, oh, it's like $13 a gallon. You go beyond that, it's getting high. And then it went to 15, and then it went to 20. And with the cost of all the equipment and stipulations, we're at cost right around $30 a gallon. And this plant is able to meet that without any issues. When you start going with conventional activated sludge with tertiary polishing, the price really gets expensive. And you always have issues with upsets and other issues, mechanical, electrical, what have you. This plant is almost a seamless production of quality effluent. And out of all the different plant manufacturers that I deal with, this by far has been the neatest, the cleanest, the easiest to operate, easiest to maintain as far as operators' time on site. So not only is it cost effective to build, it is cost effective to operate. And the one thing that I really like about this plant is that you can access everything. Operators are pretty picky. They have 3 to 4 plants that they have to maintain a day. If they can't get to something because it's difficult to get to, they are not going to do the maintenance on it that's required. They're going to wait until it fails. But if it's easy to get to it, to change the oil in motors, to change filters, to deal with leaks or other problems, they'll take care of it because it's not going to take them a lot of time. It's easy to get to. And in the long run, it is going to save them time if they deal with it when it's a little issue instead of a big issue. But that's one of the nicest things about this plant, dealing with IWS and all the problems that I've had with a number of plants. They incorporated a lot of the operational ideas that I provided to make plants easy to operate. And the next MBR is just the pinnacle of all of the comments that I have provided to them is, hey, if you do this, it'll be better. If you do that, it'll be better. And I had asked for this concrete plant forever, and sure enough, they provided one. So that has been nice.
Yeah, it's actually not my words. It's the words of an owner I was speaking to last week, and what he said is when he receives his price proposal was, this is unbelievable. You're providing, and this person that knows and has multiple CROM structures, you're providing a higher quality build. You're providing a longer lasting build. You're doing it at a fraction of the cost of a conventional system, and you're doing it in half the time. This is not what's happening in the market. Exactly the opposite is happening. We're getting less quality, we're getting longer durations, and we're getting rising cost beyond the budgeted project. And I think that's a testament to what we've accomplished here is the immediate impact of Next MBR is it's a game changer for you guys that are on and gals that are here listening in terms of delivering as engineers or owners that are on, having now an opportunity to have a next level system, a higher quality system, longer lasting system, but not paying more, paying less for it. So this isn't about marginal improvement. This is about transformational improvement. This is about fundamental change.
Yeah, and one thing I want to point out here just before we hop to the next slide is we've ran all the modeling on this. We've got standardized designs, and that cost to entry tapers off all the way down, all the way to 1 MGD, where you're right about $12 to $13 fully constructed cost at 1 MGD. And it scales out even further. So economies of scale really play into this particular modular approach.
Okay, it's just a little bit about the shotcrete system. It's a formless system, 100% shotcrete application. No vertical or horizontal cold joints that are visible in the shotcrete itself. It is designed to be resistant to wastewater because we incorporate an admixture in the interior shotcrete, and we only have to do it on the interior because of the way the system is constructed. You don't have to apply the admixture across the entire structure. You only have to apply it where you need it, and that's going to be on the inside and at the top. Really the 3 feet, 1 foot below the water level, and then above the water level. And so it's a very cost-efficient system that is designed to close the porosity of the shotcrete. As Steve mentioned, hydrogen sulfide wants to attack that bond between the cement and sand. But when you close that porosity down with an admixture, you're really able to extend the life of the system without the need of high-performance coatings. And so maybe 20, 30 years, you have to come back and you look at the system and you start to see some minor degradation. It's a local problem that can be handled locally. If you start with high-performance coatings, every 7 to 10 years, you'll be using high-performance coatings. And as I mentioned, we're using 2 exceptional standards to design and build this structure. We're an engineer-led business, so we are in designing and building in strict accordance with ACI 350, right? So the least deflections available on the market, and to the D110 water tightness standards, where CROM subscribes to zero allowable leakage. And this is what gives us the 50-year industrial grade durability and longevity. But beyond that, we know our structures are lasting. Some are now 74 years old. So the useful life beyond the design life is exceptional. And because of the uniqueness of the next MBR, we have an exceptionally compact footprint. And that is considerably smaller than traditional basins. And that allows maximum use of the facility. Everything is custom designed. And so we're able to really shoehorn in anything and anywhere to meet the needs of all the sites.
Bobby, if I might add, the one thing about the footprint of this plant compared to a conventional activated sludge plant, in Texas, we have to have a 150-foot buffer zone around the treatment units. So when you've got all the separate units that compose an activated sludge plant, the size of that footprint is really large. But when you're talking about a next MBR, it's really small. So even when you take the 150-foot buffer zone around the plant into consideration, it allows development of a lot more property that would not be available if you're using activated sludge to treat your wastewater.
That's a great point. Thanks.
Yeah, and to capitalize on that, at this particular location, they were looking at 2 times the land that was actually used. So the existing footprint for the conventional plant that was selected is allowing them to go to 750,000 gallons a day on a footprint that was originally slated for the first phase to be 310. So significantly reduced footprint. That particular facility at 250,500, like I said earlier, is 71 by 32.
Yeah, as mentioned, we had our start long before I was around, at 1953, and so we've been guaranteeing water tightness for 74 years now. And the way we're able to do that on an ACI 350 structure is to put it into permanent, or another way to say is persistent compression. So in ACI 350, you have allowable crack widths, right? The seal has to be activated when it's loaded in order. The steel needs to be activated when it's loaded. The only way to do that is for a crack to occur. Well, we prevent that crack from occurring by putting it in permanent or persistent compression. And we hold it in permanent compression for the life of the structure, right? It'll be here a lot longer than all of us, and held in permanent compression, eliminating those allowable crack widths, which causes and leads to the degradation in traditional cast in place.
When we were developing the next MBR, we wanted to make sure that we had consistent, repeatable design. So in consistent, repeatable designs, what we've done is your basic basin layout will be the same regardless of the size of your facility. So consistency across the board. The aerated zone, MBR zone, anoxic zone, and EQ zones are all in the same locations on every single one of these plants. We can reconfigure the catwalks on top. If that's something that's desired, we can make some minor tweaks and changes to the overall facility. But at 250 to 500,000 gallons a day, you're 71 by 32. When you go to 750, the plant just gets 21 feet longer. And then when you go to 1 MGD, it's as long as a 750, but the plant gets 8 feet wider. And then for other considerations, there's one thing that we haven't talked about yet is the overall basin depth on this facility is 16 and a half feet deep, with the highest water height being 15 feet. So when you take a look at that, we can also bury the structure, all but, the top foot. And so when you can do that, and you can make these facilities less apparent to the eye, a lot of them are near neighborhoods, a lot of them are near schools. And instead of being this giant concrete monument, you can completely bury this tank. The other nice feature is, and we're currently working on it, is we're standardizing sludge thickening zones onto each one of these tanks. So, with sludge hauling costs going through the roof, we're seeing 2 to 2.5x on wet hauling of sludge and wastewater presently. And so when you start looking at that, with adding a sludge thickening zone to the overall length of the tank here, it's a minimum adder as far as cost goes. And in that way, we can reduce hauling times and costs by almost 50% overall. And we use membrane thickeners in the sludge basins to do that. Steve, you want to touch on sludge hauling costs a little bit?
Yeah, one of the biggest expenses that we have, especially with a conventional activated sludge plant, is hauling off the sludge. Most of my facilities are well under 1 MGD. I probably have 10 or more under construction at any point in time. And as the operators start taking over, they're like, oh, we got to figure out a way to decant. It's costing too much to haul. The trucks are out here all the time. If there's bad weather, while they're supposed to have all access roads for all weather conditions, that doesn't always happen. So it's like the trucks are not able to get here. The truck broke down, whatever. But the ability to thicken the sludge to a little less than 3% is just awesome. The operators love it. It minimizes the number of trucks that have to come. They're not having to work with it as much to get it ready to have it transported. And I mean, most of my activated sludge plants, we're lucky to get 1.5% solids. So, you're transporting less water, you're getting more of your sludge out of there. The trucks aren't having to transport as frequently. So this makes the operators happy because they're not having to manipulate their schedule to be on site to have the sludge hauled. And it makes the ownership of the plant much more pleasing when you're not spending as much money transporting your sludge.
Sure.
And that's a big cost.
Yeah, we've actually calculated this out recently, and because we're seeing, I mean, depending on which state you're in, we're seeing prices anywhere from 31 cents a gallon sludge haul cost to 63 cents a gallon in other regions. And you start adding that up. So we did the mean average on a 100,000 gallon a day facility, and on just a 100,000 gallon a day facility, you can be saving in OpEx as much as 11,000 per month on sludge hauling costs. You add that with this system versus conventional plants. Conventional plants, you're typically wasting in the neighborhood of 10 to 12% of the total daily volume. And with MBR technology, we're only wasting between 2 and 2.3% of the total daily volume. So we're further reducing the total sludge hauling costs at that point in time by as much as 10% also.
The nice thing about, especially, we have really strict effluent permit limitations in Texas. And it's amazing. The regulatory agencies find the technology to measure something and they immediately think they have to regulate it. When I started with the regulatory agency out of college, a 1015-3 was the standard permit. We still had some 2020s, but I mean, we're getting down to almost nothing. I mean, 3511, 351.1, 33.1.1. I mean, it's amazing. And the more stringent that effluent limitation is, the more expensive your plant becomes. But the MBR technology, these membranes, are able to just make treatment an easy thing to do. If you have an operator that's competent and is familiar with the plant, then he can put out some premium effluent quality. And the last thing that plant owners want to deal with is getting hit with fines from the regulatory agency. And in Texas, it can be up to $10,000 a day. I did have one plant that got busted. Operator wasn't doing a great job. I think we paid 48,000. So it's really nice to have a manufacturer that is involved and looking at everything they can do to bring the cost of operations of treatment down. And it's not difficult. It's not really hard. And the effluent quality is great. We're doing water reuse at almost all of our facilities now. A lot of developments had used potable water for the longest time to irrigate right-of-way, parks, recreational areas. The ability to put out effluent quality that is so clean, people confuse it for drinking water when they see it. It really makes it nice to reuse that water on site instead of, if you have a municipal plant, your wastewater gets shipped to a regional location and then they just discharge it into the local tributary, whatever that might be. So the reuse has made it really nice for a number of the developments that I work in. And the operations are easy. You can check this plant remotely. If something alarms in the middle of the night, an operator can get online, they can look, and they can see exactly what's going on so that they can understand what they're going to be dealing with when they get there, or they can manipulate some of the operations from their computer to see if they can correct the problem without having to go to the plant. So these are just incredible facilities to own and operate.
Yeah, and capitalizing on that, we have a handful of clients right now that are using the reuse in some economically beneficial formats. One of our clients is using it for cooling, for chillers. So they're actually using the reuse for cooling on their larger facility. Another one is using it for a small data center. So in producing reuse out of these facilities, they're actually finding a tangible market for the reused water. And with the decentralized concrete options now, you could be looking at, right around anywhere between $2 and $2.50 per thousand gallons, depending on who the reuse is going to. Smart operations, Steve touched on it a little bit. Our current interface platform allows operators to Steve's point, to respond when appropriate or to adjust when appropriate. In other words, we go to McKinney Roughs a lot. The owner of that facility has been tremendously gracious and allows us to hold quite a few tours there on a regular basis. And one of the things that we usually get commented on when we visit that site is they ask, where are the operators? And the operator gets to take care of, a couple of other plants while he can monitor this one remotely. Next slide. So overall MBR performance, there was a point in time, where MBR had a larger CapEx umbrella to market versus conventional plants. What we've seen trending as of late is MBR treatment is either the same as conventional treatment platforms or less than conventional treatment platforms. And a good portion of that comes in the overall OpEx as you're going down the road. In other words, you don't require as much land, so you can regionalize pretty well with a decentralized system. And we're seeing a lot of developers do that. They're, getting permits for larger volumes than they're going to need for their independent development because they're anticipating additional growth around them, and they're going to be a small regional purveyor of that area. Flood management, just without thickening, we're at a 40% reduction in overall sludge generation. And when you take a look at that, you add thickening to it, then that drops even further. Optimize power usage. We go through and everything that we design around has a 10x turn down. So we do that so that we can build these facilities and manage the power consumption at them at a very high level. Getting to tight effluent limits, like Steve was talking about, as you push down and you start getting to those tighter limits, we are very conservative in these designs. In other words, we try and get to these tight limits. We have clients coming to us that are standardizing around a 0.2 phosphorus, even though they may not be permitted for that presently, and getting down to tighter and tighter limits. As we push down there, we can adjust these plants and fine tune them, to the point of where their chemical demands are significantly lower as well. Next slide. So as we work with clients across the country, one thing we're doing is we're seeing a large uptick in private utilities and towns up. When we say that, these are clients that are particularly interested in the longevity of the product overall. In other words, they don't want to be reinvesting in 15 to 20 or 25 years on a lot of the systems that we're actually replacing at this time in brownfield type applications. So as they push forward into that space, OpEx becomes a large consideration, life cycle becomes a large consideration, and being able to deliver an integrated package overall is really a huge value to them. We're also seeing the same trends in commercial and real estate, and then in some of the industrial sectors as well. For high strength wastewater streams, we can take the CROM technology and combine that with some of our other technologies prior to MBR, like jet mixing or jet aeration, and address those industrial treatment situations, and be able to deliver a very similar project for the industrial sector as well. Bobby, you want to capitalize on this? How we work with engineers?
Yeah, I appreciate that. I think a couple points are, we love partnering with the engineering houses. It's so important because they have the heart in the pulse of the owners in most cases, and understands the client needs. So this doesn't bypass the need for the engineering houses. Very similar to the CROM methodology, the engineer-led CROM methodology we've been doing for 74 years. Is we've been partnering with engineering houses. We do perform turnkey design, build, engineering, and construction, meaning we own it. No division of responsibility. The Spearman Doctrine goes away. The Spearman Doctrine issue goes away. Okay. And what's also very important, I want to reiterate this point, is this is a formless shotcrete system with 0 horizontal or vertical joints. No interior coatings required, no stripe coatings for sealing. And what's important about that is when you have a homogeneous layer of shotcrete that's put into permanent compression, you eliminate regular occurring maintenance. Okay. And so you designed by professionals, built by professionals, warranted by professionals that have been here a long time and will be here for longer than me, to continue to service the industry. And when we do that, what do? We eliminate risk. We de-risk the project, right? We provide a system that is easy to operate, lasts an exceptionally long time with virtually little or to no maintenance required.
To our Q&A.
Fantastic. Really appreciate the conversation thus far. We've got a couple questions in the Q&A box. I'll just remind the audience again, whether it's the Q&A tab or the chat tab, feel free to continue adding your questions. That being said, we'll start with one. Maintenance was mentioned in passing there at the end from Bobby. Steve touched on it earlier. We had one question regarding just on the membrane side, like servicing frequency and anything to be mindful of on the membrane side.
Yeah, absolutely. So one of the unique characteristics we have is we have 5 different membrane technologies. They all have slightly differing maintenance requirements. Typically, we're seeing CIPs around the month and a half range on average. And then we are recommending drain and inspects every 6 months. That's pretty standard. Where the beauty of it is we can drain 1 MBR basin, keep the facility fully operational when we do those drain and inspects, just to check out the overall membrane health. We can use Torre, we can use WTA, we can use BioCell L2. We have a hollow fiber alternative. So we have plenty of membrane options to go ahead and address that. And as far as maintenance and operations goes, we're not seeing a ton of issues with membranes at all.
Mhm. Um, Another question is kind of going back to, we were talking about cost in both the conventional cost estimate, the real cost at the end of this project. So whether it's Todd or anyone else, Bobby or Steve, could you just maybe drill down a little bit further on where those savings came from, whether that's primarily schedule, design efficiency, or other things? I know we touched on this, but maybe just to return to that theme.
Yeah, I can lead off, Bobby, and then you can jump in too. So the cost savings in the overall design, it's a completely vertically integrated design. So you don't have margins on top of margins on top of margins. The other place we're gaining a lot of value and savings is in the fact that we have standardized solutions, lightly customizing them to suit either the regulatory compliance rules for that region or particular items that a end user client would like to see in their facilities. So when we do that, we're able to control the cost, and deliver a high quality product to market. One of the larger cost savings is actual time on the ground. And I'll let Bobby touch on that as far as the tank construction. I mean, we're reducing it significantly by partnering with CROM on the next MBR solution.
Absolutely. Time is money, right? And if you're able to collapse your schedule by running contracting concurrent with detailed design, then reduced construction times due to the fact that you're sending seasoned and tenured tank builders that build under the CROM efficiency model, and then at the back end, that frees up the MBR process to happen earlier. All that translates into saved dollars, right? The general conditions go down, time on the site goes down, and that is money that is given. It doesn't go into the project cost.
And then further on top of that, like Bobby said, speed is, time is money, right? So in our facility down in Brenham, Texas, we warehouse over 3 MGD of components at any given time. So we're able to reduce the delivery time on these facilities significantly. Somebody needs membranes, we need membranes for a project, we have them in inventory. And we always have them in inventory. Blowers, pumps, even, control cabinets and UV disinfection units, aeration. We carry all of that in the warehouse down in Brenham, enough for 3 MGDs worth of capacity at any given time.
Yeah, I think we love, can you? We love that question.
Right.
Just recently, can you have a facility designed and up and operational by October? Absolutely. Because we run concurrent design build, right? So the answer is we can do most things that people can't. It's just, because of the true turnkey design build model, is we're running 5 paths at once and collapsing timeframes down so that we can deliver exceptional results in record time.
One other real quick, we've got a couple questions to this theme. I just noted it in the chat, but yes, we will be sharing this presentation via email to all registered attendees. So just to take care of that question out there. We have another one from the audience about whether the system can be set up for biological phosphorus removal, or is it mostly focused on nitrogen?
Yeah. So phosphorus is actually one of the key constituents that we have to treat for here in Texas. So we treat for low phosphorus limits all the time. 0.5 is on a phosphorus effluent limit is achievable just in its standard design configuration. And then obviously biological volume and mass will need to adjust that slightly to get down to tighter limits. But, basically the standard design is intended to treat those lower phosphorus limits. Like I said earlier, we have clients wanting, instead of 0.5, 0.2, or even a lower limit on phosphorus. And we're able to achieve that through just slightly modifying the overall tank design. adding a different, a little bit additional biological volume to the tank.
Got one here, I believe, for Bobby. Again, with CROM's history of innovation and kind of being at the forefront of a lot of the materials here, when it came time to for this partnership to unfold for next MBR, and this can maybe get into the weeds, but at a high level, what did it take to engineer the integration here with the MBR units for the first time?
Close coordination with the IWS team and the MMBR team, and what I will tell you is, rapid fire decision making, because when you are doing this and you're collapsing construction schedules, there's real time design and construction happening at once, and the system is incredibly versatile and allows you to make real time changes in the middle of construction. And so even wall pipe locations changed in the middle of construction, and we added them at different heights after the original wall pipes were in. Just seal them off and then add new ones. So incredibly versatile design and construction ability to be able to react to real time changes.
Excellent. We've got a retrofit question here. I'm going to read the full thing just for the context, not that it's terribly long, but would retrofitting an existing plant with next MBR technology and pre-engineered components be an option? This audience member says, we have existing aeration basins that are very similar in size to the footprint of the next MBR in this presentation that are in service with significant service life left.
So the answer is
grab the tank side. Yeah, grab the tank side and then I'll address the rest.
Say it again.
Grab the tank side and then I can address the
okay.
The balance.
So the answer is we have worked up a solution to connect into an existing ACI 350 structure. Okay, so long as it's an ACI 350 compatible structure, that's the trick. Is if it's designed to ACI 318, then we're gonna have a little bit more trouble because of the deflections in 318. So we have worked up that solution, and it is feasible. Yep.
And then as far as retrofitting into existing basins, we just a short while ago completed a facility up in Pennsylvania that was originally a 4.6 MGD facility, and we retrofitted it an aeration basin at a time and converted that facility to MBR. We were able to get 10.8 MGDs out of the exact same footprint. So we retrofitted each basin and added the MBR technology one at a time, so they never lost service at that facility until we were fully complete with the brownfield retrofit. So yes, the packages can go into existing tankage. Excellent.
Maybe continuing this thread here, we're seeing more and more MBR retrofits in general. And in fact, maybe I'll go back to this last slide. Just to bring it up here. And this may be different for the three of you, but where do you see the strongest near-term demand for next MBR, whether the municipal side, private development, industrial, and again, we can look at the slide as we're talking here.
Yeah, no. So my experience as of late has been people wanting to standardize around a solution, especially smaller purveyors or private utilities. So several of them, we have a lot of modular solutions. We have Blue Box. We've got, some expandable stainless solutions as well. And those are outstanding options if your facility is never going to be, say, bigger than 350,000 gallons a day, right? But a lot of our private utility clients, to some of Steve's points earlier, they're looking for lower CapEx. And a lot of them have purchased our smaller modular solutions, and they're moving those around from site to site to site for their phase 0 or their phase 1, if you want to call it that. And then running concurrent while that facility is online, they're designing their next MBR facility. It's highly attractive on coastal regions due to the fact that it's concrete, doesn't have a lot of corrosion issues. So we're seeing a high demand on the Carolina coast. We're seeing a high demand in Florida. We've been recently having some conversations with some utilities in the Hawaii area So that's also a big driver. And then the fact that we can meet high seismic conditions, all the way up to one lateral G with most of our equipment. We can, go into regions in California where other solutions may not reach, may not, adhere to those seismic requirements that are out there.
Yeah, I think great answer. And the answer's really on the screen. This is a custom designed system, every one. So it's the applicability is really limitless to someone's imagination, right? And so muni, private utilities, industrial clients, food and bev, marine clients, taking bilge, septic bilge off of shipping, the commercial real estate where you have lack of maybe central facilities. These big warehouses are going up and they're not able to connect in, so they're on-site treatment or even pre-treatment if depending on what they're manufacturing. Yep, all applicable.
Excellent. Well, maybe just to land on a nice concluding place as we hit the top of the hour, I wanted to ask one last question about, this is a big moment for the three of you and the teams behind you, for IWS, for CROM. Maybe to each of you, what's been the most gratifying or surprising moment, now that the project is in the ground? And I'm talking about McKinney Roughs specifically.
Want to go, Bobby?
Sure. Yeah. I love visiting the site, and I was there when the operator dropped by, and he showed me his phone where he was his tablet rather, where he was operating the facility, and I hope I don't get him in trouble. He said, "Yeah, I haven't been to this facility in 2 weeks because I can see everything is happening right here on the tablet." And seeing a facility that's crisp, it's clean, it's compact, it's easy to operate, it's smart technology. It's just couldn't be more proud of what the team has created, and the wow factor of all the visitors when they leave the site. They just couldn't be more ecstatic about what we've completed, and then to get the pricing where like, oh my gosh, and I can have all of this, and you guys are doing it for far less than what traditional facilities are costing.
Yeah, to capitalize on what Bobby said, one of the outcomes we weren't initially anticipating was our ability to go to market with it and have a very compelling value proposition as far as what it takes to get into larger facilities dollar wise for purveyors and for private utilities and developers. In saying that, it's a great product. Initially I looked at it and I said it's the miniature muni solution, right? And so we're giving municipal quality to decentralized and rural treatment purveyors, right? We're giving them that high municipal quality overall in a package that suits their demands and their needs. And that's been the nicest, surprise out of the overall project, is being able to deliver something of such high quality at such a value.
I think for me, it is how clean and concise the facility is. With all the plants under construction, I'm running around looking at plans, looking at pipe runs, trying to make sure the electrical's good. We have conflicts that happen all the time because somebody didn't really think it out. But to get here and to walk around this plant and everything is laid out in such a clean, concise manner that it's almost like you're building something with Legos. I mean, it all snaps into place and you're done. It's not like going to a conventional treatment plant and you're sitting there watching pipe runs and you're looking at the materials, making sure they got all of that right. The conflicts, ease of access. When you start getting into some really complex piping, can the operators get to everything they need to get to? valve position or the valves where you can get to them. I can't tell you how many plants I've gotten to, package plants, and a valve stuck way out, kind of out of reach from the catwalk. Like, how's the operator supposed to get that? This plant is so clean and concise. I mean, for me, it's like a dream come true. I mean, I cannot express how pleased I am with this treatment plant. Out of all the manufacturers that I deal with, this one has been the best to be able to comprehend. And it's like, I don't know where I can make improvements. I mean, they've thought of just about everything. I always have things to say, hey, we need to do this, we need to do that, we need to do the other. You can't reach this. They have got everything well placed, well thought out, and well organized. And that's what makes it really nice to be at an MBR plant. I haven't seen anything better to date.
Well, how about that for an ending note there? I want to take a moment here to thank our panelists, of course, Todd Brunetti, Bobby Oglianarte, and Steve Mendoza for sharing their time and their technical expertise. This was a fantastic conversation, and to the three of you, we really appreciate you walking us through the work in practical detail. Just a few closing reminders as we all step out. The recording of today's session will be sent to all registered attendees by email. So if there's anything you'd like to revisit, or if you want to share it with a colleague, keep an eye on your inbox. We will also be including a link to the next MBR white paper, which goes deeper on the system's design, performance data, and the McKinney Roughs case study. If you have any other follow-up questions that didn't make it into today's Q&A, don't hesitate to reach out to the IWS team directly. Keep an eye out for that email. And again, thank you to everyone for joining us, and we look forward to continuing the conversation. So thank you all.